Bismillah, Assalamualaikum. This is Statics Tutorial Chapter 3, Equilibrium of a Particle for 3D Problems. So as usual for this tutorial, we do expect you to already have covered the lecture first to understand the concept, the theory, and also, as well as the equations involved. And in this tutorial, we will be covering some past exam questions and we will try to deal with how to solve each of these questions. Right, so if you want, you can download the PDF of the questions that we will be covering in this video in the description box below. You can should be the timeline is segregated into the questions that we will be covering, and feel free to jump straight away to whichever question that you want to watch. Right. Another thing, if there is any mistakes, please do notify in the comment section below, or please do look at the comment section in case anyone already noticed if there is any mistakes going on in any of these tutorial videos actually, right? So because most of the tutorial that I have done, I do not have the time to actually properly check everything before recording, so some mistakes tend to happen here and there. Hopefully it is not that damaging, but please do try to see in the comment section in case some mistakes have been identified, right? So without further ado, let's go into the first question for today. So this is question number 1 for today. We have the diagram there where there is a structure, a flower pot or something that is being supported by the cables or the rope, and the question says, based on the diagram, determine the following. If each cable can withstand a maximum tension of 900 Newton, determine the largest mass of the flower pot and the corresponding tension in each cable. That is part A. Part B, if the weight of the flower pot is 900 Newton, what will be the value of resultant force for the forces in cable AB, AC and AD? And then part C, if the weight of the flower pot is 900 Newton, what will be the value of resultant force for all forces acting on the point A? Right. So it is interesting in this question where there are 3 parts and the conditions are different, and then we have to determine something. Right. So we will go one by one, inshallah. Right. So for part A, basically what is given is that each of these cable can withstand a maximum tension of 900 Newton, and we need to determine what is the largest corresponding tension, the largest flower pot, the mass, and the corresponding tension, right? So here, when we understand that each cable have a maximum tension that it can go up to, it doesn't mean that all of the cable actually reach that maximum at the same time. Normally only one of the cable actually reach that maximum value, right? Because when we increase the mass of the flower pot, the tension in each of the cable will increase correspondingly. Of course the value is different, so only one will reach that maximum of 900 Newton first before the others, right? So at that point it already reached the maximum, it cannot go any further, right? Any further mass increase, that particular cable will break, right? So the other cable will not reach 900 Newton, the maximum tension, right? So how to know which one reach the maximum first? So this goes to the same concept that we have covered earlier in the previous tutorial of when we deal with 2D, right? So there are similar questions when the cables, the maximum tension the cable can undergo is a certain value, but we have to decide which cable actually reach that maximum value first. All right, so as usual for 3D not for the 3D problem, for equilibrium problem, the first step is to draw the free body diagram, right? So free body diagram, and in this case it will be free body diagram of a particle, and we deal with particle A, so that particle A. And then we have all the forces, so we have one forces here which is FAC, and then we have forces something here FAB, We also have the weight going down, as well as FAD, right? So that's those are all the four forces acting at the particle A, right? So for an equilibrium problem, we know that summation of all forces should be 0, right? So if you have everything in Cartesian vector form, so FAB all in this in vector plus FAC plus FAD plus W equal to 0, right? Oops. So that is what we know. Hopefully you can see the writing on the whiteboard, right? So that is just equation of equilibrium in vector notation form, and basically it's addition of all the forces equal to 0, right? So our task is first to be able to express each of these forces in Cartesian vector form, right? So if you start from the easiest one, okay, we'll start with FAB. Okay, this one is straight away, if you can see in the diagram, it's straight away along y-axis. FAC is a straight away along x-axis. W is along z-axis. And for AD, we have to use the coordinate and position vector, right? So if we do that, maybe we'll do that first, right? So if we consider point A to D, so we have point D here, point A here, and then in that direction. So in terms of the coordinate of D is 0, 0, 2, and coordinate A is 2, 3.5, 0, right? 2, 3.5, 0, right? So from here, RAD vector, the position vector will be this minus this one, right? So 0 minus 2 is negative 2i, 0 minus 3.5 minus 3.5j, and then 2 minus 0 plus 2k, right? So RAD, if you calculate the whole thing, you should get something which is 4.5 or 9 over 2, right? 4.5 or 9 over 2. Is it correct? Okay, so if we have we calculate for unit vector of A to D, so this vector divide by this one, so we'll get minus 4 over 9i minus 7 over 9j plus 4 over 9k. That will be the unit vector. Hopefully you can see, because maybe I am writing a bit small, but I hope you can still see and listen to me while I'm going about this, because we don't have enough space. When we deal with question as long as this, normally we need all the space that we require, right? So from here you can express already what is FAD, right? It's just magnitude of FAD multiplied by the whole thing. What we are given is one of it is 900 Newton, but for now we do not know which one yet, so we have to express everything in this term, right? So for FAB vector, so it is in along y-axis to positive direction, right? So hopefully by now you already understand that cable is always in tension, right? So the direction is always meaning away to that from that point, because the cable is pulling it, right? So FAB is in y direction, so 0i plus FABJ plus 0k, and then FAC is in the x direction, positive x direction, so FAC will be FACI plus 0j plus 0k, right? For FAD, so we already have the unit vector here, it's just then multiplied by FAD magnitude, so we'll get minus 4 over 9 FAD FEDI minus 7 over 9 FEDJ plus 4 over 9 FEDK, right? And then W there, of course it is going down, so it's negative K direction, so 0I plus 0J minus WK, right, if we consider the weight is W. So we have all of this Cartesian vector notation already established, so we can apply this one, right? So you add all of this equal to 0, so if you add a summation of fx equal to 0, basically you are just adding all of this up. If you add a summation of fy, you're adding all of this. If you add a summation of fz, you have all of this, right? So this is where it helps if you make it a habit that you write everything in quite a systematic manner, right? So it's easy to see and it's easy to check in the exam, right? So I do suggest you make it a habit to be able to do so, right? So everything is in line. That's why I keep writing all of this 0, right? It's not compulsory. You can straight away say FAB equal to FABJ because everything else is 0. But it helps, especially in the exam, in the tense moment, to be able to see everything in line so that it's easy to check and double check. Alright, so with that, what we need to determine is which one is bigger than which one is smaller, right? So for summation of fx, you can compare these two. Summation of fy, you can compare these two. Summation of fz, you can compare these two, basically, right? But because we have the 3 forces, so between these two comparison, we can already determine something, right? So we will do this one. Summation of fx equal to 0. Then we'll have all of this, right? Add it up. So f is c, minus 4 over 9 f ad equal to 0. So basically f is c equal to 4 over 9 FED, right? From here we can determine that f is c is smaller than FAD, right? Because if FAD is 1, let's say FAD is 1, FAC becomes 4 over 9, which is less than 1. Alright, so if you do summation of fy, summation of fy equal to 0, you will have FAB minus 7 over 9 FAD then equal to 0. So FAB equals 7 over 9 FAD. From here you can also conclude that FAB is smaller than FAD, right? Because for example, if FAD 1, this one is 7.9, which is less than 1. So from here we can conclude that, okay, so FAD has largest force, tension force, right? So FAD equal to, what is the question says, 900 Newton. Right? So we need to find the corresponding tension as well as the mass, right? So this one is one of the answer. FAD is 900 Newton. Then we can plug in straight away here, right? So if you plug in here, so FAC, if you plug in here 900, so become 400 Newton. Right? Then FAB, if you plug in here 900, becomes 700 Newton. 700 Newton. So all the cable is settled, so we have this left. So if you do summation of Fz equal to 0, then we have 4 over 9 FAD, which is 900, minus W equal equal to 0. So W is basically 400 Newton. So again, what is the question? Question is, if the maximum is 900, determine the largest mass. So mass will be 400 over 9.81. So you'll get 900. Okay, I didn't calculate yet. So 900 divided by 9, sorry, not 900, 400 divided by 9.81. So you'll get 40.8 kilogram, right? 40.8 kilogram, and the rest is the corresponding tension in the cable, right? So basically that will be part A, where the question says when one of it is if the maximum tension is 900, what is the maximum mass of the flower pot? So this happened when one of it reached the maximum force, and we have determined that the one that reached is FAD. Alright, so that is part A. Okay, for part B, I think maybe I'll show back the diagram while reading the question. Hopefully, of course, you also have the PDF, right? You can refer to, because I do not want to erase this yet in case we need it. For part B, it says if the weight of the flower pot is 900 Newton. So the question is totally different, right? Meaning that all of this, starting from this point onwards, is not relevant, because in this case, the maximum force that each of these force can go is 900. So hence we go this one, right? But in this part B, the question says if the flower pot is 900, meaning that this W is what, 900, right? What is the value of resultant force for the cable in AB, AC, and AD? Okay, do you understand the question? Make sure you understand first. If the weight of the flower pot is 900 Newton, this is 900 Newton. Okay, this is part B already, right? So it's a different question. If this is 900 Newton, what will be the value of the resultant force? Resultant meaning, you refer back to question chapter 2, right? Resultant meaning if you add up all of this, right? Add up all of that, what will be the resultant, the value of the resultant? So you can do this two ways. One way is you recalculate everything. You put 900 here and calculate everything and then find the resultant. That's one way to do it. Another way is if you understand the concept, and it actually is very straightforward. If you understand, of course. Most of the students, when they are in exam, normally they do not take 1 minute to rethink and evaluate whether they need to calculate or not. Because in some questions like this, you can actually answer without needing to calculate, right? Because why? We already learned in this topic, in this chapter, that equilibrium means what? Equilibrium means, okay, if I write it here, that part B. For equilibrium, summation of all forces equal to 0. Right? So we already have established this one. So FAB plus FAC plus FAD plus W equal to 0. Now we know that the question gives W is 900 Newton downward. So minus 900 K Newton, right? Because it's minus 900 K, meaning it's 900 Newton downwards. So what will be the resultant force for this one? So what we need is the resultant force of all this, right? If we rearrange it, it will be like this, right? What is FR for, meaning FR of the 3, let's say like this, plus W equal to 0. Or in other words, FR plus this one is the vector, right? Minus 900k equal to 0. So Fr is 900k Newton. Okay, can you see the, hopefully you can see because there's some lighting issue there, right? So it's straightforward actually, because if you understand, the resultant of everything is 0, right? Adding everything is 0. So what is the additional of these 3? Because the additional of these 3, add with this one should be 0. So the addition of this should be the opposite of this one straight away, right? So it is 900 Newton upwards, right? So actually this part B is, I'm not sure whether it is trick question or not, but if you actually spend a lot of time to recalculate everything, then I guess it's a trick question. Because but you can try, you can prove that if you recalculate everything and then you get the resultant force of all of these 3, you will get the same answer. Maybe okay. If this is okay, where should we go? Okay, if I'm to do it here, right? If this W is 900 Newton, right? This part B again. This is 900, meaning that what is this one? The whole thing is 900, right? Sorry, because this is minus 900, so the whole thing, this one will come 900. So this whole thing is 900. Or in that case, FAD will be what? So it will be 900 times 9/4, right? That will be FAD. And then if you plug in every here, as well, yeah, I'm too lazy to recalculate, but you can try and do this, and eventually if you add up all of this again, it will go back to this answer, right? You can try. Unfortunately I'm too lazy to try, because you can straight away solve this way. Okay, that is part B. I will put again the diagram, and then we go to part C. If the weight of the flower pot is 900 Newton, so this is similar to part B, what will be the value of resultant force for all forces acting on point A? This is yet again, it's not really a trick question if you understand, because you just answer. But if you do not understand, it's actually a trick question, right? So again, if this is 900 Newton, what is the resultant force for all forces? What will be? The answer will be 0, right? Because it is just that part C, right? Part C. So for equilibrium, summation of all forces equal to 0. That's it. Because the question simply asks what is the resultant force for all forces acting at point A, right? Acting at point A. Of course it is 0 because it is equilibrium. So that is this question. So I'm not sure when this question came up in the exam previously, how did the student do? Because if you can see from what we have covered, part A is basically calculation, part B and C is basically just simple calculation. This is not even a calculation, this is a statement, right? A simple calculation based on your understanding. Alright, so hopefully you understand. Any question, any comment, please do put in the comment section below. Hopefully I can understand what you are concerning about, etc., if any. Alright, so I think we can go to question number 2. Okay, this is question number 2 for today. We have the diagram on the right there. We have a structure where kind of a box is hanging, and then we have 2 springs, right, and 1 cable there. So the question says, part A, determine the stretch in each of the 2 springs required to hold the 20 kg crate in the equilibrium position shown. Each spring has an unstretched length of 2 meter and a stiffness of K equal to 360 Newton per meter. And part B, should the spring stiffness of each of the spring be higher, lower or the same to hold the crate in the same position as shown if the crate is heavier? Explain your answer. Right. So if you can understand the question, part A is basically calculation based and part B is just understanding based, right? And it does help if you understand and if you have already solved part A, and then you can understand what's going on in the calculation. Right. So again, as equilibrium problem, we always start with a free body diagram. So we have free body diagram, and then we have point O there. FOA somewhat like that, so FOA in the y-axis, so FOB is an x-axis, negative axis, so FOB, the angle is somewhat, alright. FOC somewhat like that, and then straight away down is the weight, right? So basically that will be the free body diagram. So yet again, this is an equilibrium problem, so summation of all forces equal to 0, or FOA vector plus FOB vector plus FOC vector plus W equal to 0. So the exact same thing as before. The additional of all forces in vector form equal to 0. Right, so FOA is along a line, so it's straightforward. FOB is along a line, straightforward. For FOC, you have to consider the coordinate, right? So we will do that first to get the unit vector. So from point O to point C, right? So O is the origin, 0, 0, 0. Point C is 4, 6, 12. 4, 6, 12, right? So given this is the case, so ROC vector will be this minus this one, so 4i plus 6j plus 12k. Alright, so if you calculate the magnitude, okay, I'm too lazy to write everything, but you should properly do it, right? And then if you do this, you will get what? 14. Right? And then unit vector of OC, this divided by this, so you'll get 2 over 7i plus 3 over 7j plus 6 over 7k. And this you just divide by that. So from there, we are ready already to express in terms of vector the force, because this multiplied by the magnitude, you'll get the vector. Okay, so we express everything. So starting from FOA, so FOA vector is, so the force OA is along y-axis negative. Okay, we assume, okay, now for a spring, the force can be either way, right? Because spring, if you compress, it will want to push back, so it will push back. If it is being stretched, it want to return back, so it will pull back, right? So that's the two possibility of spring. But in this case, we can assume it is pulling, right? One way is just assumption. Second way, it's actually logical, because if you understand, cable OC will be in the direction towards C. So obviously the two spring will counter in the two axes so that it is in equilibrium. So that's just logical, right? But anyway, we can just assume. So I already assumed the direction there, right? So I already assume OA is in the negative y-axis. So 0i minus FOA j plus 0k. For FOB, I already assumed as well in the negative x. So minus FOB I plus 0j plus 0k. And then for FOC, we already have the unit vector here. So FOC, the vector is just multiply this with of OC. So we'll get 2 over 7 FOCI plus 3 over 7 FOCJ plus 6 over 7 FOCK. And then we have the weight, which is going down. So the weight is 0I plus 0J minus WK. The question, does it give anything? So okay, sorry, the question already give the weight, right? The mass. So weight is just mass times gravity. So the mass is 20 kilograms. So 20 times 9.81. This should give, what is it? What is the value? 196.2, right? Newton. Okay, that is given from the question, the mass, right? So actually the free body diagram should already include the known value. So this is known. So if I'm to write it straight away, it will be that value, right? 196.2 Newton. Alright, so once again we have expressed every forces in Cartesian vector form. So we can see that if you do summation of fx, you get this one, summation of fy, you get this one, summation of fz, you get this one. So from here you know where to start, right? Here you can see that, oh, okay, I can solve summation of fz first to get this FOC. Right, why not do that? Okay, so if you do summation of fz equal to 0, then you add all of this, should be equal to 0. So 6 over 7 FOC minus 196.2 should equal to 0. Right, now do not skip steps in this case, right? For example, this is equation of equilibrium, the original summation of forces equal to 0, and then you actually do the summation equal to 0, and then you do the calculation. If you skip this step, then you actually never express summation of all forces equal to 0. That is vital steps, and if you skip that, you will lose that mark, right? Avoid that. Okay, so from here you can calculate FOC equal to something, right? So please verify the number whether this is correct. Hopefully it is. Becomes 228.9 Newton. Right. Is that the question? The question asks for what is the what is it? Determine the stretch. Okay, how much the spring have stretch. Right. So we are not. The question actually do not ask for the force, but it asks for the stretch of the spring. So we have to calculate the force first before we can go there. Right. So FOC is that now. So FOC is settled, then we can solve all of this, right? So we can do, for example, summation of fx equal to 0. So minus of OB plus 2 over 7 with this value 228.9 should equal to 0. So FOB you can calculate to be 65.4 Newton. And then if you do summation of Fy equal to 0, you get 3 over 7 FOC, minus FOA first, minus FOA plus 3 over 7 FOC, which is 228.9 equal to 0. So FOE you can calculate to be 98.1 Newton. Alright. As usual, do verify all the number. 3 over 7 to 8.9. Okay. So what to do next? We want to know the stretch of the spring. So the stretch is coming from, meaning we have the equation for spring F equal to Ks. S is the stretch, meaning the length that it elongate, right? So we know the force, we know already the K. K is given as K equal to 360 Newton per meter. right? So for spring OA, we can use this force, right? So for spring OA, so because for F equal to Ks, so S equal to force divided by K, right? S equal to F over K. So S OA equal to FOA, which is 98.1 divided by, this is Newton, divided by K is 360 Newton per meter. So you'll get something in meter, right? So if you do that, 0.273 meter. That would be the answer, right? The stretch. Now SOB is FOB, which is this one, 65.4 over 360. So this is Newton per meter. You divide, you get something in meter, and then you get 0.182 meter. So hopefully you can see the point, because someone from the previous video says the point is too small, right? Hopefully you follow, because all the points hopefully when I verbally mention the numbers, you follow, right? Okay, so that would be the answer, right? So at least this part you can see 0.273 meter and then 0.182 meter. So that is the stretch. Now some student actually in the exam raise their hand and ask, wait a minute, we didn't use, if you look back at the question, it says the unstretched length is 2 meter. Unstretched length is 2 meter. So we don't even use that value in our calculation, right? So now my response is just simply, why do you bother about that? You already get your answer, so just ignore anything else, right? So sometimes, just to mess with the students, some extra information that is not useful in the exam, in the question itself, is being given, right? For example, the unstretched length. But when you are calculating for stretch, right, the elongation, the original length is not important, right? Why do I care, right? So yeah, it would be different if the question says what is the total length, meaning that you have to add original length with stretch, etc., right? So that will be different. So make sure you really understand what you need to find, and do not be confused by some information, extra information that is given, even though you do not need to use it in the calculation, right? So sometimes the lecturer are evil like that. Not evil, just want to, test you whether you understand or not. All right, part B. So again, I put the diagram back there, and question part B: should the spring stiffness of each of the spring be higher, lower, or the same if it is to hold in equilibrium in the same position if the crate is heavier? So what do you think? Alright, so here it says you need to explain, right? So one way is by using what you have already here, just referring to question A, part A, right? Because if, okay, based on what you have calculated, right, if this mass, because this is from the mass, right, goes higher, right, what will happen? Will this go higher, FOC? If this goes higher, this will go higher as well, right? Meaning FOC, it will go higher as well, correct? If FOC goes higher, meaning this one goes higher, FOB will go higher as well, right? Similarly here, if this goes higher, FOA will go higher as well. And if, okay, my marker is already, if all of FOA and FOB, this one goes higher, then obviously the stretch will be higher as well. Okay, if this is the narrative as before, but however, the question says to hold it in the same position. To hold it in the same position, then the stretch should not be changing, right? The stretch should be remaining, meaning S should be remaining, because otherwise the position will change. So the question says to hold the crate in the same position, meaning that everything should be same length. So S should be exactly the same. So to remain at the same when FOA and FB is increasing, K should be lower, right? Oh, K should be higher. This is a test. Actually, K should be higher. Right, from here maybe you cannot see, right, but logically it should be higher as well accordingly, because if this go higher, they should go higher as well to get the same number, right? Or we can go back there. If S remain the same, if F goes higher, K should go higher as well, right? Yeah, so as well as we can explain that in a simple narrative what is going on, you have explained your answer, and the examiner will give you the full mark for that part B, right? So it's just to understand what is the chain reaction happen when something change, how it actually affect in something else down the line. All right, normally question like this, the marks is mainly on the explanation part. If you just guess or tembakan, oh higher, lower, etc., normally you do not get anything, because that's just you just shoot something, right? So you have to explain, because most of the mark there is about the explanation. All right, so that is question number 2. Moving on to question number 3. So this is the third question. We have the diagram on the right, and then the question, part A. A small pack P rests on a spring that is contained inside the smooth pipe. So if you can see the diagram, you can see the spring inside the smooth pipe. When the spring is compressed so that L equal to 1.2 meter. So you can see the diagram, there's L there to the distance of the height. So the question says L is given as 1.2 meter. The spring exerts an upward force of 80 Newton on the peg. So we know already that the spring push up with upward force of 80 Newton, right? So the peg is being pushed up 80 Newton. Determine the tension in chord PA as Cartesian vector. If the tension in chord PB and PC equal to 45 Newton and 39 Newton respectively. Alright, so 2 of the cable is already given what is the value. For PB it is 45 Newton, and for PC it is 39 Newton. Also determine the coordinate of the point of attachment A, x, y, 0. So you can see point A, the distance is not yet known, so it is x and y, right? So the coordinate will be x, y, 0 of the chord PA. Alright, so part B, okay, we'll go to all the question first. Part B, use dot product to find the angle between chord PB and chord PC. Right, so the question already specify you have to use the dot product to find the angle. Part C, is it possible for the spring to have an original length more than length L, Y? And part D, is it possible for the spring to have an original length less than length L, Y? Alright, so part C and D is basically related question, so that is understanding question. Right, so the diagram is on the side. Let's go for question part A. The question already gives a certain value, right? So if you do the free body diagram of point P, right? So we start with free body diagram. Have point P, right? So at point P, the question already state that the spring is pushing it up with a certain value, which is 80 Newton. So that this is given, right? And then we have force PB, FPB, FPA, and FPC, something like that, right? It should be downward, more downward, right? Now some value are given. So PB is 45 Newton. So this is 45 Newton. And PC is 39 Newton. So in this case, the only unknown is FPA. Right? Okay. So that is what is given. So the four forces acting at point P. Right. So in equilibrium, so we know that summation of all forces should be equal to 0. So in other words, if we know the vector of FPA plus FPB plus FPC, plus F, let's label this Fs, for example, for spring, plus Fs equal to 0, right? So if you add all of these vector forces, force in vector form, it should be equal to 0. Right, so how to express each of these? So it will go back to how we use coordinate for each of these, right? So of course for FPA, we do not have the coordinate, so we will use just x, y, z component first, right? But for PB and PC, we already have the coordinate, so let's do that. So for PB, where should I do this? I'll do it on that side. Hopefully you can. Okay. So if you consider from point P to B, right? Point P is 0, 0, 1.2. 0, 0, 1.2, the coordinate. Point B is 0, minus 0.90, right? 0 minus 0.90. So from here, RPB would be 0i minus 0.9 J plus 1.2 K. Right, hopefully you can see the numbers because the dot, the decimal point will be small, but yeah. But you know how to get these values, right? And then RPB, the magnitude, if you calculate, you will get 1.5. Okay, I'm too lazy to write everything, but I believe by now you know already what is going on inside. And then UPB is just this divided by this, so you have 0i minus 3/5 J plus sorry. Okay, I made a mistake. There, it should be negative, right? Okay, that is a mistake. Okay, 0 minus 0 is 0, 0, negative 0.9 minus 0 is negative 0.9, 0 minus 1.9 is negative 1. 0 minus 1.2 is negative 1.2, right? So it will become minus 4/5 over here. Okay, that would be the unit vector for this one. Of course, FPB, the value is already given as 45 Newton. So if you do FPB, the vector is 45 Newton multiplied by all of this, right? So you will get 0i minus 27, right? Minus 27J minus 36K Newton, is it? This is all in Newton, right? Okay, that is for PB. Okay, I already expressed it there. Never mind. Okay, we'll do for PC, right? So PC. So P is the same coordinate 0, 0, 1.2. C is 0.3, minus 0.4, 0. Okay, so RPC with this minus, so 0.3i minus 0.4j minus 1.2k. So RPC, if you do the square root, what do you get? 1.3. Right. So you do UPC divide, we get 3 over 13, right? Oh, sorry. Okay, I did make a mistake. Allahu Akbar kabira. This coordinate is wrong, right? Because I thought this is x. Okay. We'll redo it again. So, okay, this is the effect of doing the work at 3 a.m. in the morning. All right. So okay. Wait. Okay, this one is correct, right? X is this one, y is that one, right? Okay, so x is minus 0.4. Sorry, x is minus 0.4. Y is 0.3. Z is 0. Astaghfirullah. Okay. So it will be negative 0.4 I plus 0.3 j minus 1.2 k, and then you do the square root, you get 1.3. So of course you divide this, you get minus 4 over 13 I plus 3 over 13 j minus 12 over 13 k. Okay, so FPC is given already. FPC, the magnitude is 39 Newton. So you multiply by the unit vector. So FPC, the vector, you will get, you multiply minus 12, right? So minus 12 I plus 9 j, is it 9? Minus 36 k Newton. Okay, so that is basically what we have done in chapter 2, right? Okay, so we have expressed FPB, FPC, FAA, we just use unknown because we do not know yet. FS is just downwards, right? Okay, so if we rewrite everything here, so FPA we'll just write as, for example, FPA XI plus FPA YJ plus FPA ZK, meaning that this is just 3 unknown. That is what we want to find, right? And then FPB, where is it? Yeah, that one. So 0I minus 27J minus 36K. And then FPC is minus 12I plus 9J minus 36K. And then FS there, sorry, FS is going up, right? So it's K. So 0I plus 0J plus 80K. So 80 going up. Okay, so hopefully there's no other mistake in that part and in this part. So from summation of forces equal to 0, we can see that doing summation of fx you can solve this one, doing summation of fy you can solve for this one, doing summation of fz you can solve for this one, right? So if you do summation of fx, summation of fx equal to 0, so basically you have PAX minus 12 equal to 0. So F PAX equal to 12 Newton, right? And then summation of Fy equal to 0 for this one. So F PAY minus 27 plus 9 equal to 0. So F PAY will be 27 minus 9 will be 18. This is Newton, right? Is it 18 Newton? Okay. And then summation of Fz equal to 0. So you add all of this. So F PAZ minus 36 plus 80 equal to 0. Is it correct? So F PAZ equal to minus 36 minus 36 becomes 72. Bring there, 72 minus 80 is minus 8, right? Minus 8 Newton, meaning that it goes down. So you can check the logical, whether it is logical, because if you see the diagram, if I place back the diagram, FPA, the direction should have positive X direction, positive Y direction, and negative Z direction, right? So that's, if it's tally, then at least it is not obviously wrong, right? Hopefully it's right. You can check the value, right? So positive, positive, and negative. So what is the question back again? The question says determine the tension in chord PA as a Cartesian vector. So you need to express this as a Cartesian vector. So where can we do that? We can do that. Is there any space? So I'll just write it here, right? So FPA as a vector equal to 12I plus 18J plus 18J minus 8K Newton. So 12I plus 18J minus 8 Newton and minus 8K Newton. So that is the tension. Now we need to also determine X and Y. Okay, so this is where it gets interesting. How? Okay, I'll put back the diagram there. How do we calculate for X and Y from what we have? So I think I can erase this one because we already get FPA, and we just need to use FPA to get X and Y, right? So this one is over, so I'll erase this one. Alright, so we'll do. Now from the diagram, there are only two important points here, right? From point P to point A, because in terms of the coordinate, A is the X, Y, 0, sorry, and coordinate P is 0, 0, 1.2, right? So how to get this one? Because this is basically the opposite way of calculation, right? Normally we have the coordinate, we calculate the force vector. Right now, from the force vector, we want to calculate the coordinate, right? So what can we do? Right, one way is, because we have where do we have okay, because normally what we do is we calculate AR position vector, and then R magnitude, and then unit vector, and then multiply unit vector, you get the vector, right? So now we are trying to do the opposite way, right? If we have position vector for this one, right? So it will be R PA, it will be XI plus YJ minus 1.2K. right? And if you want to calculate the magnitude, then it will be square root of this thing, right? For example, if you write it first, if you do not know what to do yet, we write it first, we'll get square root of x square plus y square plus 1.2 square, right? And then unit vector is this divided by this, right? If we calculate that unit vector, unit is basically all of this divided by all of this, right? So xi plus yj minus 1.2k over square root of x square plus y square plus 1.2 square. Or we can write it separately, like x over this one I plus y over this one j plus or minus 1.2 over this one k. Now that will give you UPA. What do you have here is already this one vector, right? So FPA is 12i plus 18j plus minus 8k. So we can get the magnitude, right? When you do this, you get something. So let's see, you get 12 plus 18 minus 8. If you do this, you get 23.065 Newton. Okay, now if you divide this, right, FPA with FPA vector over FPA magnitude, what you get, actually you get UPA, right? Because unit vector of PA is any vector along PA divided by its own magnitude. So if you do this, basically you'll get, if I do this, you get 0.5203i. Also, of course, verify the numbers. Can you see this one? Okay, I'll write down. There's some lighting there, right? Plus 0.7804j minus 0.3468k, right? So that is just unit vector here. So this should equal to this, right? Because it's the same unit vector. You can check whether it's unit vector or not. If you do square root of all of this, you should get 1, right? Now okay, so we can do one by one, is it? Okay, we do Z1 first, because if you do Z component, so let's say we do Z component first, basically minus 1.2 over this whole thing for the K component, right? So minus 1.2 over square root of x square plus y square plus 1.2 square. This whole thing equal to minus 0.3468, right? That whole component x z component, it should be equal to this z component. So if you do this calculation, so if this brings there, okay, so if you do, okay, it will be like 1.2 over 0.3468 equal to this over there, square root of x square plus y square plus 1.2 square. Okay, this is a bit more mathematics than what normally we do, but yeah, we have to do it. So if you verify the number, this becomes 3.46, right? Okay, so if you open this square root, meaning you square both sides, this square and this square, so this one will get 11.973. 11.973 equal to x square plus y square plus 1.2 square. If this 1.2 square you bring it here to so you get 10.533. 10.533 equal to x square plus y square. Now, when we do it, we know this thing here, we can just replace with this one, right? Because we know this value already, right? So this one we can plug in inside there, right? So for X component, for example, for we just say the X component, where we have X over this whole thing. So sorry, X over square root of the whole thing, but this here is 10.533 already, right? Plus 1.2 square, right? Because X square plus Y square, everything is that 10.533 already. We know that. This should equal to, for X is 0.5203. So if you calculate this one, you solve this one, bring up over here, you get X equal to 1.8. Right? And then you do for Y component, you get the Y over the whole thing. So Y over square root of 10.533 plus 1.2 square equal to, and then Y component here is 0.7804. So if you shift this and you calculate, you get Y equal to 2.7. So what you need to determine is the coordinate. So meaning that final answer is A coordinate is X is 1.8, Y is 2.7, Z is 0. That is the coordinate. Alright, so this is a bit more mathematics than normally I do like to do, but when you have this kind of question, you just have to try to solve using all the mathematics that you know, right? So of course this part is still statics in the sense that, okay, how to relate, right? So we have the vector. So if you are stuck, and because this is not a normal question, in the meaning that it reverses the flow, but even if it's so, you can just, okay, it's reverse the flow, so I can retract back what I should do, right? Because if you do have the point, you can have the coordinate, even though it's in this form. Never mind, go forward first, and go forward first. And then you know unit vector, if you understand the concept, unit vector is just any vector divided by its magnitude. So it can be R, it can be F, or anything. So in this case, we have R, we can have F already, so we do just make the similarity between unit vector here and unit vector here, and then get the X component, Y component, Z component, you get this coordinate. Alright. That is part A. Let's move on to part B. Alright, for part B, actually this question is not from the theory of chapter 3, it's from chapter 2, which is angle determined by using dot product, right? But regardless, we will try to just refresh. Hopefully you still remember, because in the exam, it can just mix all the chapters in one question like this, part A, B, C, D, right? So yeah, even though the diagram is the same, the question can be off from whatever chapter that we have learned. So make sure you understand that. So part B, just to refresh, it is angle between PB and PC, right? So okay, PB and PC, right? So what is the angle here? So the concept that we will be using is simply just A dot B equal to A B cos theta. So for example, we know the vector that you can use is RPB dot RPC equal to RPB RPC cos, what is this? Cos theta, right? And because we have already established from part A what is RPB, RPC and the magnitude, straight away plug in all those values, right? So if you plug in all those values, because this is from chapter 2, I'm just showing this, just the big steps. So from here you just plug in, meaning just put all the vector of RPB from part A you already calculated just now, RPC, and then the magnitude, and then you can calculate for theta. So basically you get cos theta equal to 3/5, theta equal to 53.1 degrees. So that would be the answer. Okay, so part C. Is it possible for the spring to have an original length more than L? Why? And part D is actually the opposite way the question asks, right? Is it possible for the spring to have original length less than L? Right, if you understand from the free body diagram, from the original free body diagram, you have the spring pushing it up, and then everything else is a cable, right? So everything must be going towards that downward direction because everything is cable, right? The cable cannot push the how to say the point, the particle, right? So for equilibrium, for summation of forces equal to 0, the understanding is, is it possible that this force from the spring to go down? Is it possible? If you understand, you will know that this is not possible, right? Because if everything is down, nothing is going up, it is impossible to be having this, right? Because it will just go down. Everything is pulling down, nothing is holding it up, it will fall down. It will not be in equilibrium. So it must be going up, right? It must be. For it to go up, the spring should be, because right now the length is 1.2, right? It is currently here, and the spring is pushing up. So the spring originally should be longer or shorter than 1.2. This is just logical if you understand how a spring works, right? So the original length should be higher, right? Because if it's like this, for example, and then you push it to this position, it will want to return back to its normal original position, right? So it will push up, right? So that will be the logical original point. If the spring is originally here, right, shorter, if you pull it up, stretch it, it will want to go back to the normal length, and then it will pull down. But this is not possible. So what for part C, is it possible to have length more than L? Yes, that's the logical explanation. That's the only logical explanation, because the force should go up and the original length should be longer, right? But for part D, is it possible for the spring to have original length less than L? Not possible, because in that case the force will be going down and equilibrium will not be achieved, right? So that's basically question number 3. Let's move on to question number 4. Okay, this is the fourth question for today. The diagram is as shown. You have like a crate, like a box hanging there, and then you have the cables, you have the rod as well as a spring, right? And then the question goes, the crate of weight W is being held in the equilibrium position shown. The crate is supported by two cables OB and OD, a spring OA, and a rod OC. The cables have tension of 500 Newton each, and the spring stiffness of spring OA is 1.2 kilonewton per meter, right? So the cables, the two cables, the question already say that each have 500 Newton, right? So first, draw the free body diagram. Second, express each of the forces as a Cartesian vector. Third, what is the mass of the crate that can be supported? Fourth, what is the unstretched length of the spring OA? And then finally, if spring OA is replaced by rod, what will happen to FOA? Give reasoning for your answer. So we'll go one by one. So in this case, because the question is structured in a way that it is bit by bit. So first part is draw free body diagram. So in a free body diagram of point O, right? Free body diagram of point O. So we have point O. Okay, let it be a bit down. Point O there. So we have the weight going down. So the weight W, it says. And then we have force of a spring in the negative y, something like this, FOA, okay, something like that. And then we have FOB at a certain angle there, FOB. And then we have FOC there, the rod. And then we have FOD here, right? Okay, now the thing is FOB and FOD is confirmed the direction is as such because it is cable. For spring FOA, it may go either way, right? Because spring can push and pull, depend the original state, etc. And for the rod, can also push and pull. So meaning that FOC is also assumption. So FOA and FOC is assumption, basically the direction. So we will have to see. Right. So, but with our assumption, that will be the free body diagram. Right. And as well, of course, there's the angle, etc. But in 3D, normally just highlighting or illustrating every single force, that is sufficient. Okay, then part B, express each of the force in as Cartesian vector form. Right, so FOA is straightforward on an axis. FOB, you have the projection angles given. FOC, also you have the triangle. FOD, you have the alpha, beta, gamma. Basically, the weight is downwards. Okay, so we have the information given, right? But of course, for okay, we'll do one by one. So for FOA, okay, FOA is simply the negative y direction, right? So equal to 0I negative FOA J plus 0K, right? Of course, the question says express every forces as a Cartesian vector, right? So this is one. So it is in Newton, right? Is it in Newton? It doesn't say, right? Okay, is there any value given? Oh, okay, 500 Newton, so it's in Newton. Okay, so Newton, that's it. Okay, I forgot. Free body diagram is not complete because we have to read back the question what it gives, right? Because sometimes you forgot. I forgot. So it says, the question says the cable have a tension 500 Newton, meaning cables OB and OD. So this one is equal to 500 Newton and FOD, right? This one is 500 Newton. So in free body diagram, all the known should be given the number, all the unknown should be labeled properly, right? So if you miss out the number, you just, like I just did, you'll just miss out several marks, right? Because the free body diagram is not complete. Okay, FOA is complete. FOB, we have to use that 30 degrees and 70 degrees, right? So FOB is basically the value is 500, right? So for X it will be 500. Okay, sorry, it will be negative X, negative direction, right? Minus 500 and then cos 70 degrees and then sine 30 degrees, sine 30 degrees I. And then for Y component it is negative as well, so minus 500 cos 70 degrees cos 30 degrees J. And then for Z is going upward, so plus 500 sine 70 degrees K, right? So this is from chapter 2 understanding. So we just calculate and get the value. So for FOB you will get, what is the value? Minus 85.5 minus 85.5 I. Do check the numbers as well as of course. Minus 148.1 minus 148.1 J plus 469.85 K. Newton. Now, why I do take a lot of significant numbers of figure as possible, because we will use still all this value for the following question, right? So we shouldn't round off that much. But if, because part B it says what is the answer in terms of Cartesian vector form, so you can write your answer, for example, round off this is to 3 significant number. But this one for the calculation should also be there. Do not round off for the answer, but then you use the final answer for calculation, because then the error is quite big already, right? Okay, that's FOB. FOC, basically you do not know the value, but you know the triangle, right? So you have the triangle 3, 4, 5 there. If you can see the diagram, hopefully 3, 4, 5. So x component is, okay, so x component is negative, right? So negative FOC 4/5 I. Y component is 0, so plus 0g, and z component is plus FOC 3/5 K Newton, right? So that is basically FOC. What else? FOA, FOB, FOC, FOD, right? FOD. Okay, for FOD, because the information that is given alpha, beta, gamma, we only have alpha and gamma, right? We do not have beta in the diagram. Yeah. So we have to use that cos square alpha plus cos square beta plus cos square gamma equal to 1. Right? Remember this mathematical formula. So yeah, you just have to memorize this to apply. So it is, from the diagram you can see that alpha is 60 degrees, gamma is 60 degrees. So cos square 60 degrees plus cos square beta, we do not know, plus cos square gamma 60 degrees equal to 1. So half square plus cos square beta plus half square equal to 1. So half, so 0.5 square plus 0.5 square, and then so 1 minus answer, so cos squared beta is 1/2, right? So square root of 1/2, right? So cos beta, you'll get square root of 2/2. So beta, cos of the answer 45 degrees. Okay, verify. Please do verify. Is this correct? Because okay, it's 3:30 AM. I'm already sleepy, that my brain is not working as fast as it could. So right, so cos 60 half square 1.4, of course 1.4 plus 1/4, 1/4 equal 1/2. 1 minus 1 divided by 2 is half. Cos square, so square root of half is that one, and then arc cos, that one is 45 degrees. Okay, so I assume no mistake there. Double check, of course. So 45 degrees. So what do we have? Because we are using alpha, beta, and gamma for FOD, right? So FOD is 500 cos 60 degrees for I, and then beta becomes plus 500 cos 45 degrees J plus 500 cos 60 degrees K. Right, that's gamma. So okay, this is vector. So FOD for 500 cos 60, do you get 250i? Oops. So 500 times cos 45 degrees, you get plus 353.6 J plus 250K. Right, so that's of OD. Just check whether this gives you the actual magnitude, right? If you square root of 250 square plus 353.6 square plus 250 square, you get 500, right? Okay, so we have done the expressing each of the forces. Oh no, not each yet. 1, 2, 3, 4. So W. So where should we put W? Okay, I'll continue up there. So W is just 0i plus 0j minus wk. Then we have express each of the forces as Cartesian vector. Right? FOA, FOB, FOC, FOD, W. Next, what is the mass of the crate that can be supported? Right, so okay, like I mentioned in the previous question, I like to arrange accordingly so that it's easy to see the summation of forces. Right now it's quite hard to see, right, because one is here, one is here, one is here. But anyway, we need to find the mass, right? So if you for mass, summation of Fz, right, of course. So here Z you have the value, here you don't. Here you have the value, here is 0, right? So by solving Fz first, we cannot solve it yet. Okay, let's try one more. For Fx 0, number, FOC, a number and 0. So you can solve FOC first and then we can go there, right? So doing summation of Fx equal to 0. So 0 minus 85.5 minus 4/5 FOC plus 250 plus 0 equal to 0. Right, so we have 1, 2, 3, 4, 5 forces. So from here FOC you can calculate, right? Allah. Okay, so what is it? 85.5 multiplied by 5 divided by 4. Okay, sorry, you have the number first, right? So you have what? 250 minus 85.5. So you get a certain number here, and then you bring it that way. So multiply 5 by 4, you get 205.625. 205 or 0.625. That is FOC. Okay, now we know this already. Can we solve for W? So if we do summation of Fz equal to 0, here is 0, here is plus 469.85, and then plus 3/5 plus 3/5. FOC is this one, 205.625, and then FOD is plus 250, and then minus W equal to 0, right? So W should be able to calculate by just computing this, right? 469.85 plus sorry, 3 times 5. Okay, I'm too sleepy to even calculate this correctly. Astaghfirullah. Plus 3/5 multiplied by 205.625 plus 250. So you get 843.255. Is it Newton? 225, sorry. Okay. 843.225. Okay. So this is what I'm facing right now is a reminder to you that do not sleep too late or study up too late before exam, right? Make sure you study way ahead. Before the exam, if you try to study, your mind is already too slow, right? This is already near 4 a.m. Okay. Alright, so okay, the question is what? Mass, right? What is mass? Okay, so mass is 843.225 divided by 9.81. So we'll get divide by 9.81. So you get 85, basically 86.0 kilogram. Right? So that's the mass. That's part C. Okay, bismillah. Part D. A little bit more. Part D, what is the unstretched length of springs OA? Okay, so we need to find OA, right? And then we need to find the spring length. Okay, for FOA, so we need to do summation of FY. Summation of FY equal to 0. Is it still clear? Still here? Okay, wait a minute. Do you see this one? Hopefully you can see. It's 86 kilogram. You can calculate yourself and just verify. It is 86 kilogram. If nothing is wrong. Hopefully nothing is wrong. Okay, so here you have minus FOA for summation of FY, right? And then minus 148.1 plus 0 plus 353.6 1 2 3 4 and then plus 0 equal to 0, right? FOA 148.1 0 353.6 and then 0. So meaning that FOA we bring on that side, it will give you have 353.6 minus 148.1. You get 205.5 Newton. Verify the number as usual. Okay. And then what is given? Given is spring of, okay, this is quite interesting because the unit, right? K is given as 1.2 kilonewton per meter. Right, so I will continue to calculate over here. I think we do not need, we do need this. No. So simply just F equal to KS, we need to find the unstretched length, right? We need to find LO. So in the diagram, if you can see back the diagram, because where should I put the diagram, because we have the value here. So in the diagram you can see that L is 1 meter, right? So L is basically L naught plus S, right? Or L naught is L minus S, right? So we want to find S here. L we know, then we can find L naught, right? So from here S equal to F over K. FOA is 205.5 Newton. K is 1.2 kilonewton per meter. Okay, so this is where it is beneficial if you actually write the unit, so then you realize that you cannot straight away divide because this is kilo, right? So in other words, it's 1200 Newton per meter, 1200 Newton per meter, right? So if you divide as such, so 205.5 divide by 1200, you actually get 0.171 meter, right? So if you have 1 meter there, so 1 meter minus the stretch, which is 0.171, now LO becomes 1 minus 0.171, 0.829 meter, right? So meaning that the original length, the unstretched length, is 0.829 meter, and when it is stretched by this value, it will reach to the current length, which is 1 meter, right? Okay, so that is the unstretched length. Hopefully you understand that, right? So you get 0.829 meter, the unstretched length. Okay, again, make sure you realize that the unit there, there's kilonewton there. Of course, there's a hint. Of course, if you just straight away divide, you'll get what? 800, is it? 80, is it? Meaning that something that is it logical if that is the case? It's not logical, right? Yeah. Anyway, part E, if spring OA is replaced by a rod, what will happen to force FOA? So this force FOA here. Okay, if you look back at the diagram, what will happen to the force if you replace spring with the rod? Give your reasoning, right? So generally speaking, if this is the case, because if how to say, equilibrium still maintained, so basically the force is still the same thing, the same way, right? And just that the rod will be under compression. No, sorry, the force is in that direction. Okay, the rod will be under tension, right? Because it is being pulled in the other direction, but so yeah, it will maintain equilibrium by being under tension. But of course, we haven't learned that yet in this chapter, I think, in terms of whether it's tension, compression. Normally we talk about it in a rigid body. Of course, when you do the exam, you already have covered that chapter as well, right? So that is where the question is combination of many chapters in the exam, right? So it's not purely from one chapter, right? Hopefully you understand that. So in this final part, or the logical part here, inshallah you will understand later when you have covered rigid bodies, right? So that's it for this tutorial, inshallah. Hopefully, please forgive me for all the shortcoming. My mind is not functioning at the optimum level here because it is too late already. It is almost 4 a.m. But I have to rush to make this complete so that I can post it, so that you can have, meaning you can watch the tutorial before before the time that you need to watch. Okay, I'm already mumbling here, so I think we should just end the tutorial session. Hopefully this has been beneficial for you, inshallah. Hopefully you understand what we have covered today with the 4 exam question from past exam. Alright, so make sure you understand how to draw the free body diagram, apply equation of equilibrium, as well as whatever else that mathematics that come in, what you have learned before about trigonometry, etc. Make sure all of those you understand, because even with one of those elements missing, you might be stuck even though you understand some concept, right? So make sure you have to understand everything that you need. Wallahu alam. With that, we end the session. Subhanakallahumma wa bihamdik, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamu alaikum warahmatullahi wabarakatuh.